So let's wait a minute for Christian.
Oh, so I'm like taking notes. So if I look down, that's what I'm doing. No, I'm still paying attention years later.
Yeah, Christian. So I take a minute break. I wait for Christian and come back.
Oh, so I did. Yeah, are you there? I think you submitted the wrong thing for the report.
Yeah, actually, when I submitted, I think like the overleaf, it first up the report while downloading. I actually edited it after some time, but I think it didn't register. So I'll just message Ron and send him the correct one.
Okay. I think it would be good if you could update on the Git as well, because to be very honest, I kind of do check everyone's in a way so I know what's going on a bit.
Yeah.
Yeah.
Actually, I talked with Ron with my like previous report about what the my contribution should be, and we talked about maybe creating a framework or like an analysis report that needed to start and run experiments like showing the performance of our algorithm in terms of like resolution or depth or width. So I think maybe I should work on that a bit more. Because I searched about it, and maybe in the sequential setting we can offer like an asymptotic improvement in circuit depth and size, as well as in the number of ancilla qubits, or while like considering a more parallel setting obtained by decreasing circuit depth at the cost of increasing circuit width.
Yeah, I think we can look into that later. We can discuss the one is further work, I guess.
So hi everyone, I'm excited to meet again. Once every 2 weeks is a lot of time. So I guess a lot happened in the last 2 weeks. And as far as I remember, it was a great presentation to Abu last week. So good job. So this meeting is mainly for you. We are in a stage that I think that it's reasonable to start to write the article in 2 weeks from now, because there is now a lot of time, and you can also, while you are working, you can start make sure that you have LaTeX in everywhere. It will be easier to write an article. It means that a lot of work has to be done in the next 2 weeks if you want a nice article with not a lot of pressure of making rounds of making sure it looks good. So maybe 2, maybe 3 weeks, but if I look at let's look at the deadlines. If I look at the syllabus of the course, so I see that December 19 is complete the missing reports, and January 2 is paper writing and presentations. So and final presentation is in the 23 of January.
Oh, but I think the schedule is 1 week early now. Yeah. So basically the 19th, I think it should be pushed back 1 week most likely. Or I mean to check with Abu for that, but the presentation is definitely all 1 week later now. Yeah, like for example, the 5th progress report, like the last report is 1 week after December 12th. Because
okay. Great. So give us some more time, but I think you've done a lot of work so far. I think that it's a good point to start to focus and to arrange things and to get to make analyze of your results, and to be in 2 weeks in a way that you can look at your work and say, okay, I think I I've done the most of the work and I know what I've got and I know how to present it and something like that. I don't know. So this meeting is mainly for you to ask questions. I will be happy that you are welcome to share the work that you have done. If you want to, anything you want to present and things that you feel like, oh, I achieved this. This is nice. And then from it, look and talk about what are the gaps, what are your future work. And I will be happy to help you to plan anything and to synchronize what you're going to do. So maybe just briefly, each one of you, 20 seconds of what you plan to talk about.
I'll probably talk about what I have done and like some thoughts about what needs to be done to bridge between what we're working on. Yeah.
Hi, everyone. Good morning. In my case, I'm reading all the things related to phishing information. I have learned a lot of that, but perhaps I have some doubts regarding the how to proceed the data. So if you agree, I would like to present what I have done this week and to show you what is the question I have for the next step.
Okay, sounds perfect. And I will tell already now that for me, the best, as I see it, to connect the work of Simin and you is to show a match between theoretical analysis and experimental analysis. And Aditya, what about you?
Yeah, so like we talked about with the previous report, I think my part should be like analyzing and comparing the results. So like the framework needed in terms of comparing our algorithm, the optimized one in with the one presented in the paper. So I researched that a bit, and in terms of offering an improvement in the number of like measurements required to estimate the phase with precision, I should work on that.
Amazing. Sounds very good. Great. So who want to start? Simin, maybe you is the...
Yeah, sure. I'll start first. I'll share my screen. Oh, share screen. Wait, oh gosh, I pressed the wrong thing. How do I? Okay, I need to unshare it first. Sorry. Share screen. Okay. So basically, during the first week, this one I presented in the presentation already, but basically the two-phase situation I have that created, but I haven't worked on more than 2 phases, and currently it's given as like a 50-50 amplitude right now. So like that's not good. like I feel like that's too even, so it's not really reflecting any. Yeah, like in real life it wouldn't be that case. So yeah. So that's one thing I eventually need to work on. But in the past week, this is what I've worked on, is that I've been like analyzing a bit, like not analyzing, like comparing the current accuracy, the error compared to this one is number of shots. Yes, I believe the number of shots here. Yeah, and then the other one is the error again against the number of qubits, I think. Yeah, number of qubits here. So that's what I've been working on mostly. Yeah.
Amazing. So you probably, did you read my comment about logarithmic scale? So
Yeah.
you can see much better how you improved. This is something that was changing, and my guess, once you will find the resolution as a function of the estimation register size and the number of shots, maybe as a formula, it will be interesting to see how much the estimation register size is actually implementing. Maybe it not so influence on the resolution, because what I saw when I try to play with it, that once you increase your numshots, you can get fantastic results with only 3 of estimation register size. Maybe you can go to 4 or 5, but once you go to 7, it's very difficult to synthesize it. I don't know how did you even manage to synthesize, because classic, as far as I tried, it took me maybe half an hour to synthesize a circuit with the size of 6, because the depth is very big. But anyway, maybe it's not necessary. So it's something that worth trying to check. This will be a very nice. You can also maybe together with Aditya to do it, yeah. But there is a lot of work here. Maybe a nice thing to do will be a function that is asking you what is the resolution that you want, and is giving you the recommendation of the numshots and the estimation register size. Maybe up to constraints. Maybe some hardware are limited by the depths. And there is something you can give optimal, and you can also give it up to constraint and say, okay, let's look at this hardware. The constraint is maximal numshots like this, or maximal estimation depths like this. So this is my answer. And also maybe building, maybe this is too much work, but if you are limited with numshots, you can also always run again and again. Let's say you are limited to 10,000 numshots. Okay, you want 1 million, just run the 10,000 100 times, and it will be doing the same work.
Regarding that, just now what you were saying, right? I have a question, which is you left a comment on the GitLab there, and you mentioned like the 10,000 or 10 billion, or you can't remember how many. That one is the number of shots, right? Firstly. Yeah. Okay. And also another thing I wanted to ask about the function they were saying just now, the resolution. That one is like basically we compare the error, right? Like that resolution, we find what is the corresponding error, and then we find what's the number of shots, for example, based on your past results in a way. Yeah. Okay. And I have one more question. The one more question is, okay, currently right now my number of shots is like very little right now, mostly because the one in the paper was very little. So as you've mentioned, we can like don't directly do with the paper, but of course there's that comparison which is good, which Aditya was also mentioning just now. So basically I will need that version, but for many num shots. Yeah. Does that make sense? Like, I don't have that right now because that's not the portion I'm working on. So I can't really compare it directly.
Okay, yeah. You say it is limited.
Yeah, like right now, like I don't have the data for their method for like 10,000 num shots, because that is like 100 right now or something. So that's also why I only did 100.
Why can't you do it with 10,000?
I can do it with 10,000, but I can't compare it with theirs of 10,000 because I don't have their current model of 10,000. Because in their paper, I don't think they have such a high number.
Okay. It doesn't must to be comparable exactly to there. It can be something that about comparable. Maybe it's not also the ultimate reference that we should compare to. Maybe there are more articles that talk about post-processing. You can look for it. But just what I wanted to say, I forgot. Okay, maybe.
I'm so sorry. Yeah, I wanted to clarify that. But on the same topic, then just now, I think Aditya was saying to compare the models. Then maybe actually Aditya could work on like implementing an old model, for example, and then we can compare it. In that way, it could be the paper model, it could be a new model, like another model that we find, like a benchmark model to compare the current model to, in that logic. Perhaps.
Yeah, you can find another things to compare to, but you can also by it absolutely by itself and not relatively to another thing. It can be very useful, like conversion of the exponential depths into exponential amount of numshots. For example, this can be like a subtitle of what you are doing, because this is actually what we are doing. I've got this realized only lately, that instead of making a depth in the naive way without the post-processing, a depth that is exponential in the resolution, instead of doing it, you do a small depth, but you pay exponentially in the amount of shots. So it can be like a subtitle for this. And just a moment, sorry, I'm trying to remember. Yeah, sorry, maybe later.
Okay, thank you.
Is this answering what you asked? Yeah, okay. Sorry, I thought about something that was important for me to say. 1 minute. Another interesting to do is to say not only what is the accuracy you've got, you can also talk about how many resources did you save. Because if you get some accuracy, and for the same accuracy, you have to take a depth which is very big. So this is how much you saved. If you got accuracy of 1e minus 6 with only 3 estimation size registers, which means the depth is 2 to the power of 3, which is 8. And for this exact accuracy in the old way, you have to take estimation register size, I don't know, 15, and the depth was 2 to the power of 15. So you saved exponentially in depth. So this is like a parameter that you can present on a graph of how much you saved, what was supposed to be the depth if you didn't use this technique. And this is another way to present why this is good.
Thank you.
Thank you. Aditya, would you like to continue and to maybe connection to what Simin is doing?
Yeah, so maybe I should share my screen first. 1 second. Yeah, so like these two parts present what I was doing. These are essentially the bullet points and on the right, and the left one is the one I'm working on in like comparing or analyzing the performance that we get from our algorithm. So like we talked about creation of the framework needed to start and running experiments that will show the performance of our algorithm in terms of like resolution, num shots, depth, width, etc. So like when starting, there was some mention of like we define the depth of a quantum circuit as the number of time steps where the gates of disjoint qubits can occur in a parallel of a given time step. So like the width of a quantum circuit is the number of qubits, and the size of a quantum circuit is total number of non-identity quantum gates. So whilst comparing from the one I read was comparing the Kitaev's phase estimation and the one they created on their own, and in sequential setting, the fast estimation like it offers an asymptotic improvement in the matter of circuit depth and size, as well as in the number of ancilla qubits, and like in a parallel setting obtained by decreasing the depth, it comes at the cost of like increasing the circuit width. That is one thing. The other thing I found like recently was that the impact of incoherent noise on quantum phase estimation indicate that the standard deviation of the eigenvalue of the unitary operator has strong exponential dependence upon the error probability of individual qubits. So like we can also work on how like low noise in terms of the current quantum computers available commercially is affecting our algorithm. And we can like we can also use the one I read about was using like an M node cluster of quantum computers, and how their algorithm requires essentially how much time in that they required constant time. We can maybe compute how our algorithm requires how much time, or like in addition to improving efficiency and failure rate, you know.
Wow,
That's
this sounds super interesting, because I had doubt about is this algorithm is useful in the NISQ area, and how the noises will affect this post-processing. Maybe it will take it very much away, or we can still do something useful. Do we need the fault tolerance? And perhaps using this, maybe we can faster get to quantum advantage without having fault tolerance by just doing this process. Maybe, I don't know. So I found this very useful and interesting. It can be a great chapter in the article. Actually, also I wanted to tell you, please notice that some other techniques are having the theta rotation in the entrance after the Hadamard. We are doing differently. The theta rotation is taking the quantization and making it more accurate, that instead of the result being between two possible options, it put it on the spot. And we don't do it. We do the same circuit. We don't try to change theta, which is perhaps maybe also not accurate. It's not, these gates are not very accurate. It has some resolution of theta. So we do the regular phase estimation, but another post-processing. Yeah, so what you wanted to say, I stopped you.
So actually, this idea actually came from like a very recent work done by some like neighbors of ours, essentially. So what they did was, like, in their work, they wanted to study the impact of incoherent noise on QPE, and they modeled it as like trace preserving and completely positive quantum channels. So essentially, the work that they did was simulation and analysis of QPE algorithm in the presence of incoherent quantum noise channels, and they like the simulation results indicate the standard deviation and all, and the different noise channel such as like depolarizing, phase flip, bit flip, and bit phase flip are taken to understand the performance, essentially, of this algorithm in presence of noise in the commercially available computers.
Super interesting. Amazing. Go on, keep going. It's very important. I wish that you will have enough time to make a very valuable results from that. I'm sure you will. You have the 2 or 3 weeks. I don't know. You have to do a lot of effort here, but I'm sure you will, because if you find this and you have this in your mind, I'm sure you will do something nice. Okay, great. Hey, Christian, did the summary of estimation theory I sent was useful, or it was too messy? Because I have some printed copy of the course that I made in my university, so I looked for the pages that relevant for you, and I was wondering if it was helpful for you.
Yeah, the note you sent me was very useful. Yeah, I have been reading them and other references just to understand a little bit more all this math about fishing information, because, as I mentioned before, this is a new topic for me. I had just read a little bit about quantum feature information from some works, previous works, but all the classical development and the stuff, the things about this log function, etc., likelihood function, etc., is new for me. So I was reading all the things, and I have some. I would like to show. The short analysis I have right now. So this is the report I sent just this morning. So this morning here in Colombia, because I was reading and understanding some of these things. So up to now, I understand the following. This is the probability function we have that we are using to fix the parameter, the observables data we have for the base estimation algorithm. So this is called the log function, or log likelihood function, that is just the logarithm of this p. And if you plot this function with respect to the parameter y for a fixed theta, you get what we saw, for example, in the wallpaper. Yeah, that this is the mean psi loop and of course the highest values is on the actual value of theta.
Is this 3 pi over 8? Because I saw you wrote theta is pi over 8, so I was expecting the center to be up to the 1, y equal 1.
The center is around pi because of the function is this one. So theta have pi over 8. So the highest value of y should be pi. Let's see. Yes, pi. So this is this value are for the very beginning example.
It's a bit different definition, I think, maybe for theta. Maybe theta is running. Never mind. Keep going. Just convention.
Okay. Yeah. So what I mean is that, of course, if we know the value of theta and we analyze the...
Yeah, I'm sorry that I'm stopping you again. Just it might be important because maybe once you try to synchronize with CMIN, maybe you will have different convention for theta. The one can say that theta is a phase between 0 to 2 pi, and the other can say this is a floating point between 0 to 1, and you have to convert it. So just please make sure you have the same convention of what theta is, because I expect that when you take theta to be pi over 8, so it means that y have to be equal 1 in the maximal probability. But just convention, just please make sure you can go on.
Okay. So after that, of course, there is a function called the score function or log high likelihood function. That is just the derivative with respect to theta of the logarithm of p. We use this score function to get the feature information. So what I did was to compute this quantity here, the score function, the square of the score function times the same probability function. And of course, we have a function for a function that, let's say, is the feature information in terms of the parameter y and theta. So of course, in the same, if I run the same example, I mean just taking theta to this value, pi 8, and we plot this feature information with respect to y. So the inverse of the feature information function, 1 over the feature information. Of course, it's clear that the minimum value of this inverse function reaches to in this value of for theta in the horizontal axis. So from the mathematical, it works very well, but I understand that what we have to do is coming from the data, the observation we have. So basically, what I think that I have to do right now is to manage to deal this analysis from the data coming from the points, the data used by CMIN in her algorithms. I'm not sure how to deal with that because I understand that, for example, if I get some points, some data, and for that data I obtain the log of those values, I should see something like this profile. So just for me to test this function over those data. But I'm a little confused because for me, this is basically the same that CMIN has done right now so far. Because of course, I plot different values data and make a curve fit using this P. For me, it's the same that take the log of those data and make a course fit or a mathematical analyzing over this function. So I'm a little confused about the how to manage these analysis on feature information from the data, from the real data we are using for testing the algorithm, for the post-processing, I mean. So basically, that is what I have to clarify right now. So I mean that I understand that the estimator, let's say the best value of theta of the phase, is given by the maximum of the curves that C-mean have been fitted. I'm not sure. So I mean that from the curve fit given by her, I can extract the maximum value of the probability distribution, and for that it would be the best value for theta. So if I take this value and put in into my my log function or my feature information, I would see the best fit from this mathematical analysis, but I'm not sure. I would also understand a little bit more this example here. Let me show you in one of the references of the dual paper. There is this example of phase estimation. They did the same analysis, but they consider that the phase estimation, this cosine function, is into a Gaussian noise. So the probability distribution is different. It's an exponential function, but they computed the same quantities, and after that they give an approximation for the feature value, the feature information value. But they say that this is an example in which the phase estimator doesn't exist, which is unbiased here, this part, unbiased and attains the Kramer-Rao lower bound. So I'm not sure if this is the same case for us because of the function is quite similar. So I need to understand what does it mean that the estimator doesn't exist. So I'm reading about it, and I would like to clarify some of these things just to proceed to take, if I correct, to take some data from the experiment did by Simin and to fit this mathematics into it. So I'm not sure if that is the correct way to proceed.
Okay, so let's try to make order, and I will share my screen and we think loudly. You're gonna probably be more expert in feature information and estimation theory than me. After you will do the deep understanding, and I can try to bridge as far as I know, the material that is relevant. So let me share my screen. I looked for the examples I sent you, and let's read together and understand. I don't have like quick answers because it's not something I deal with every day with estimation theory tools. It's things I did a few years ago, so I try to remind with you now. But the basic idea of estimation theory is saying I have some black box which is hidden some value of some parameter. This is what we call theta, and I can make random measurements. It can be the weather, for example. I want to know what the temperature in Finland, which affect only thing I can measure is the temperature here. So theta is hidden in some things that is acting randomly. So if we look this very simple example, let's say that I have some random variable x. K is the every time I measure it. It has a mean value of theta that I look for, and there is the addition of the Gaussian noise. This is very simple, very similar to what we have, because we don't have a Gaussian noise, but we have this shape of sync that has some distribution. The center of it is theta, just like X. X also behave like a Gaussian with the center of it is theta. So the distribution of X with many samples is multiplication of all the one sample case. Each one of the sample, just one X, just one dimension, is behaving like a Gaussian with the center as theta. So it's very similar to what we have if we examine just one thing. For one sample, I know that the X in our case is Y, and I have many samples of Y, and the probability to get a lot of Y in very specific state measured is the multiplication of all the possibilities, but it's independent. Each one, this is why we can multiply everything. And then we can do the same calculations. And the calculation of score is something that I have to say that the Fisher information and score and Kramer lower bound is not something that depends on our estimator. You can estimate in different ways. You can find theta in different ways. For example, you can take the mean value of Y if you had many samples, and this is also an estimator. It is not what we do, but there are many possible estimators. Why I'm saying it is because the Fisher information is not coming to tell you something specific about your estimator. It's not looking at the estimator at all. It's just telling you how easy is to find theta from some given distribution. And the score is telling you how separable is one theta from another theta, how reasonable this can be for you to find it. So this is very important. It was not clear to me when we started. I understood it after I read again this material. So this is something that tells us about the how possible is this at all to understand how if any estimator in the world could find in a good resolution what the theta is. So this is the lower bound for actually if you do 1 over Fisher information, so you get the MSE of the estimation of the best theta. MSE means the error. This is actually will be the resolution of finding theta. So as long as Fisher information is bigger, so we could easily find more. And additional, so Fisher information is talking about only one sample, and there is a theorem that I sent you that is proving that for many samples, for n samples, the sum of all the Fisher information on all the different samples will give you the total Fisher information. So this is where numshots come. And it actually means that numshots multiplied by one Fisher information of one sample will give you the total Fisher information. So this is about the Fisher information. Now, this is first question. This is making this is more clear this way now. Before we continue, yeah, I would expect that the Fisher information does not have to be dependent on Y, because Y is a random variable, right? If we go back to the simple example over here, so let's see here. So the score, this I have multiplication of all the samples, and the score depend because you do log, so the multiplication is becoming summation of all the samples. So it does depend on Y, sorry. it does depend on y. But the score, because y is a random variable, so the score has some distribution. It's something that is probabilistic. So it's analytically calculated, and you find it as something that is not dependent on the specific samples, but just as a theory, saying, okay, y is a random variable, and the score is also a random variable, and there is some relation here. This perhaps simpler case because this is Gaussian and we are not Gaussian. What else I wanted to say? That, oh, okay. So the score is a random variable, but the variance of the score is telling me about the Fisher information. When the variance of the score is very big, it means I have more Fisher information because the score has wider distribution. And if I have wider distribution, I'm looking for the place I saw it. So it means that theta is more separable. It means the resolution is better. Here, you see here that the score in this simple case has a distribution that becoming with bigger variance when I have more samples and when I have smaller sigma, smaller noise. So the score has wider distribution, right? This was not very intuitive to me. I have to think about it why, but let's say that we agree on that score with bigger variance that distribute wider give me more Fisher information. And then we can say again that the definition of the Fisher information is also the variance of the score here. So this is why it's the expectation value of the second derivative of the score, the Fisher information. So the most important thing from here maybe is to understand that it's not dependent on our estimator. But what we can do, because now we have to find this missing detail here is the relation between the MSE. We said what the MSE is. The best MSE that you can do from given distribution is 1 over Fisher information. And now what you can do, Simin can take the MSE is the resolution, is the error. The error is as a straight relation with the MSE. So Simin can tell you, okay, I calculated this MSE, this error, this resolution, this was my MSE, and you can tell her that the best MSE possible in the world for some given sample and some given this distribution is 1 over Fisher information. This is the Kramer-Rao lower bound, and you can show on a graph the gap between the best possible in any estimator in the world and yours. And if you show a match, it means you found the best estimator ever, and no one theoretically can ever give you a better estimator than that. Is this clearer now? Yeah.
Sure. I have a question about the MSE portion, the last part. It's a mean squared error, right?
Yeah.
Okay. Then this mean squared error, right? So there's a lot of error. So am I supposed to take it like in the same plot, the graph, then like the error of like the different y's compared to the actual one? Or is it supposed to be like many different of these graphs and finding because I directly have my theta already from the estimated one, from the curve fit, I mean.
Yeah, so maybe let's think of how many different variables you have. You have different probabilities, like different thetas you're looking for. So this is one variable. So I think you randomly choose every time another theta, right?
No, I'm quite confused because I currently use 1 theta for the single phase case, right?
Okay, so it's important to take few thetas because some thetas will give you better results than other thetas, especially in the naive approach. In the naive approach, if you give a theta which is exactly on the ladder, on the scale, so you get the best resolution. So it's important to randomly choose few thetas, and you can average them. So one variable is different thetas. You can choose equally separable or maybe randomly chosen in uniform distribution. The other one is num shots. and the estimation register size, it's also another variable. And perhaps that's it for now. And maybe the MSE should be calculated as the average MSE over different thetas. And MSE will be different as a function of, you can show a graph that the horizontal axis maybe num shots, and you can show how the MSE is decreasing as you increase the num shots. But MSE, maybe the best is to take an average over different thetas. Maybe you need to think how to graphically show it as a function also of the estimation register size.
Okay, thank you for that. But I'm still a bit confused because currently, for example, so firstly, I'm not clear if the Fisher information really captures the information because its best MSE is 1 over Fisher information, right? And then another concern is that since it's starting theta, num shots, register size, should I normalize all of them? Or they're on very different scales of values. Yeah.
Why do you have to normalize?
Because if I take different, so basically I start each experiment with a different one of each, and then take the different outcome error theta.
But I think that if you look at the units of Fisher information, so since it's the second derivative of theta, so it's like 1 over the square of the units of theta. So maybe you just have to take the square root of MSE or something like this, and it will match with the resolution.
Wait, actually just a square will work, right? 1 over that, so it will be a theta square. So my estimated theta error and that I square the error, it will be the same units, right? MSE.
Yeah, maybe if you take the square of the resolution, perhaps it will match the units of the MSE. I'm looking here. You can see the MSE equal to the variance of the estimator. This is the definition of the MSE. It's asking the mean square error, like how far the estimator is from the in the case of unbiased, is from its mean value. Where the mean value should be the actual answer. So this is the variance, and this is the should as Kramer lower bound, it should be bigger than 1 over Fisher information. And as you can see in this case, for example, for a coin with distributed with Bernoulli, in this example. So this is again the units are the units of theta square. So it seems fine, and it's becoming smaller and smaller as you decrease the number of samples.
Okay, thank you. And sorry for interrupting, Christian probably has a question. Yeah.
It's okay. Christian, is this clearer? It's clearer also for me now. I didn't understand what I want to say before I started to say.
Thanks, Ron. No, for example, when I read the example you just show us, I understand those examples. I understand how arrive the mean, for example, the mean for the estimator, right? But because of in the phase estimation case we have, I understand there is no there is not an exact lower bound that you can achieve. So
maybe present your screen again. Maybe we can look together and think how you could keep developing it.
So, for example, in this example, there is a
Sorry, I think maybe it can be confusing. Maybe I meant to show what you calculated in your paper, because this is phase estimation of classical.
Okay.
this has a very this has its own complexity. So here again, okay, let's see. We have the probability distribution, and you calculate the log. Let's go next below the graph, and you calculate the score. Okay.
For example, I have a question here because if I look for the definition of the feature information that you write when you said that the feature information doesn't depend on y, only on theta, is because here you have the sum over the sample of this expression. Of course, if you make the sum, that is not trivial in this case. So you have a function only on theta. But
Yeah.
I'm not sure how to manage that function because when I sum over y, I'm not sure if I'm doing wrong there. I discretely sum from 0 to 7. So I just give a number from 0 to 7, natural number for on y. But when I
have to you took the score squared, but you have to, the definition is the expectation value of score squared. So it means you have to sum
yeah, true.
over all possible y's, no?
Over y, yes, of course, yes. That is what I mean. If the definition of the feature information is the expectation value of this expression, the score square times p, yeah.
Or
So
maybe integral over y.
That is something that I have in the. Let me show you the.
So it does not depend on y anymore. If you sum all over all possible y, or maybe integrate over all possible y, it does not depend on y anymore.
Exactly. So basically, that is one of my questions. So the sum on the sample must be discrete, or I should consider like an integral here. I'm not sure. But basically, of course, if I sum over the sample, this function is a function only on theta.
Yeah.
Yeah. So let's say
it will be easier to see the some theta will give you better resolution, some will be worse. Yeah, of theta.
Okay. So something that I did just to test what I was doing was I don't have a close expression for this sum. So basically, I just run the sum and plot the feature information from different theta. But so let me show you. I did this using Wolfram Online, so no Python. But I'm not sure because about this. For example, if I just define, let's say, feature information as the sum over the samples of the previous expression, and I plot this function, I get something like this one. Just a peak on 0, and the rest of the function is only 0. So I'm not sure what that means.
This is surprising. I wouldn't expect to see such a thing. By the way, maybe the scalings that we talked before, the units of theta, perhaps it's as a relation. I don't know. We don't have a lot of time to debug this if you want to do by yourself, and if you like to schedule another time. But it is surprising. I would expect to a feature information that is big enough for all thetas with no discrimination.
Something like this one. But this is because.
But it's only on the peaks here. I expect even more than this one. Maybe for all the thetas, not for only discrete thetas.
Ah, okay.
Because because if this is 0, it means that you get a resolution that the MSE is infinity. So it is surprising. Maybe actually the one below, if you go down, this is perhaps maybe something more reasonable. I really don't know. If you struggle with this, let's talk again. But it does surprising. I would expect something that is not
because I did something. I did the same, but for the log function here. So if you can see here, if I plot the function in terms of y, just for a fixed theta, this is what I get. But if I sum over all the samples and I get the log likelihood only in terms of theta, I have this kind of plot, but I'm not sure how to explain this. What does it mean?
Yeah, it's look very.
This is the log function in terms only on theta after summing over all the samples.
Yeah.
But I'm not sure if I'm doing well the sum because I just considering the discrete sample from 0 to 7, 0, 1, 2, 3.
Yeah, it's look weird. We don't have enough time to dig in this, but it seems like you're in the direction and maybe just a bug or something to make sure. Anyway, we can keep talking on Slack or maybe to make another appointment if you like, and to look carefully step by step. It will be a bit harder to do it now.
Okay.
Christian, could you send this like some sort of PDF or something of this thing to the Slack, and I can take a look at it too?
Sure. I'm going to organize this information, even run or correct, and I will send you.
Okay. Anything else? I have to finish 2 minutes before. Any questions? Before it looks for me like you are in a great progress. I think it's gonna be amazing work, honestly. Any questions? Anyway, I will be available for you in Slack or anything. If you want to schedule anything, you can feel free to talk. Aditya, please also notice I saw that you sent a mistake file in the report, so make sure
Yeah,
you do.
actually, I think Overleaf did that. I was, editing the file, and I think it fuzzed up a little bit while exporting. I edited that comment, but I don't think it registered. Maybe after you comment it, I'll take a look at it again. I'll see what the problem was, or maybe if it doesn't work out, maybe I'll comment on it again.
Great. Okay. Bye, guys. A lot of success with your work. Bye-bye.
Thank you, you all.
Thank you.
Bye. See you.
Bye.
Bye-bye.
Do y'all want to talk for a moment? Christian, I already noticed one bug, by the way. Is that you aren't supposed to use pi over 8, you're supposed to use 1 over 8 there, because if you look in your own math, right, do you want to share screen, by the way, or are you busy? If you're busy, you can go, I can type it out on Slack.
No, don't worry. We can meet a little bit more.
Okay, then do you want to share screen on that, just now that document, and then the first portion, the pi over 8 portion? I can point it out what is the reason. I mean, we could use pi over 8 too, but you have a pi square. Yeah.
For P, you mean in this expression?
Yeah, basically you will notice that there's already a 2 pi over there, and then it's like so-called multiplied with the theta over there. So if your theta was pi over 8, you will have a 2 pi square over 8. And I mean, pi square is a really awkward thing.
Yes,
Yeah.
I remember I saw that in your work. So basically, this 2 pi is multiplying here. So your y is my 2 pi y, and for you theta is my 2 pi theta, right?
No, yeah, basically, but I end up not using my version. I actually end up using your version because I wanted to standardize a bit. That's why there's that confusion. I think you tried to use my version. Yeah.
Okay.
Sorry for that. I'm so sorry. Yeah. Yeah. So I basically use your
Tell me.
So basically, I use your version now. So as a result, your theta can never be pi over. Well, can, but pi over 8 would be very weird because it would do pi square over 8. Yeah. So I think 1 over 8 would be better over there. Yeah, but I understand why it was 3 also just now. Yeah.
Okay.
So
Okay.
that's the thing. And also, I think I'm not sure if you're clear about this, but on my work, right, the curve that I fitted, it's like basically they calculated directly what's the theta for me, and I fitted the curve. I showed the curve on it to show the fit after that. So technically, like my algorithm directly returns the theta that they estimated. Yeah, I'm not sure if that's very important, but it does do that. Yeah. I think that's the main part that I can talk about. I'll also go and calculate my MSE based on what we discussed today, and then whatever that Ron mentioned in reply to mine, I'll also try to work on that. Do y'all want to discuss your work, or do y'all want to? I mean, you guys can do whatever plans you want.
So I'm not sure I understand well what Ron said about the different theta you have to consider in your experiment. What, because for me, you have what you have is the histogram given by the algorithms, the QPE algorithms. So for those points, you fit the curve, the probability function. So I'm not sure what did Ron means when saying you that you have to consider several thetas.
Okay, the reason for that is there's 2 parts to this reply. To his reply was that firstly, the thetas, like they could be more biased in a way, like some thetas are easier to estimate than others. So as a result, if I want like a accuracy estimate, I should test different thetas so that I can see like on average how does it perform in that sense. Does that a bit make sense? Yeah, and then the second portion that oh yeah, and then so basically from that different thetas, I will be taking the mean square error based on those.
Okay.
Yeah,
Okay,
which is
I see.
related to your official information. Yeah, that's it. I'm if that's clear. If there's anything else you can ask. I'm very confused about the official information stuff, so like I'm sorry.
No, I'm also confused about that. I have been reading many different portals of references, but it is completely a mess for me.
Yeah.
Yeah.
Yes. So do you want to discuss what you plan to do over the next 2-3 weeks or so, or
So to be honest, my principal objective for the next week is to understand this sort of thing about fishing information. I have to read other references, and now I have to think a little bit about the last plot I showed you, because I'm not sure what is going on there. Yeah, because for example, in the definition of the fishing information, the sum over the sample is part of the definition. But when you compute the expectation value, you have to make or another sum or an integration over the sample. So I'm a little confused about that. So I'm going to read and to clarify that. Mhm.
regarding that work, right? I wasn't very sure. What is the x-axis? Is that the theta, or is that what's the x-axis basically? Is that the y? Is that the yeah?
Excuse me.
Just now that plot that you showed, the one that you are confused about, which I'm also very confused about. But what was the x-axis?
In the plot of the log function, let me show you.
Okay.
Here. So if you take the log of our probability distribution in terms of y, you can plot this one. So this is the horizontal axis is y for a fixed theta. So the parameter theta is fixed to pi/8. But in terms of the definition of the feature information, we have to sum over y. So if you take this expression and sum over all the sample the values of y, you get a function that is only in terms of theta. So basically what I did here was to plot the log function in terms of theta from 0 to 2 pi. So the horizontal axis here is theta because y is sum over.
So the bottom one, the one that's very weird, is also to theta.
For the feature information, for the feature information, this is just one single function, feature information in terms of y. So here the horizontal axis is y. But if we take the sum over y, the feature information is just a function of theta. But when I plot the feature information from 0 to 2 pi for theta, just summing over 0, 1, 2, 3, 4, 5 until 7 in this example, this is the plot I get, but I'm sure this is not correct. So I'm not sure how to fix this.
Okay, thank you.
But okay.
Does Aditya want to talk about your plans?
So, like I talked about creation of the performance aspect, maybe I should maybe start a thread in the Slack channel in which I can, collaborate more, all three of us, and maybe I can share what I'm drawing from, like the standard model which I'm drawing from, and like various forms of comparison we can do. Also, the thing I talked about of the incoherent noise channels, maybe that would be a better way, and that way I can send you the papers that I'm actually reading and the ones like that talked about the recent research work that they did. So I got like their math equations, and maybe I can share them as well.
Okay. Math is something I can't really talk about either. I mean, do you have more like apart from what you plan to send us, which I think those are work you have basically already done in a way. Do you have like further plans you get to test are you gonna test it between another model and our model, or are you gonna test it between, because I am working a bit on my model, but I have nothing to compare it to, for example. Yeah.
The thing I talked about, like they used a different model. They used a global standard model. Maybe we can work on that as well. And also, like while performing, like comparing performances, they use like the Kiatev's QPE algorithm, and showed how the algorithm is actually fast performing in terms of that. So we can do something like that also. That's why I talked about maybe I can start a thread and we can bullet point wise work on which is a better way to move ahead.
Okay. Then wait, I feel like I was gonna say something. Okay, so basically maybe you can work on more of the comparison side, whereas I'm working on my like analyzing our own model right now. So like that's part of my work right now, but you can do a comparison portion, which is definitely not something I'm working on at all, I think.
And also the thing that you talked about the num shots thing, that was maybe creating a problem for you. Like what was that? Maybe we can work on that as well.
Oh, it's not really a huge issue, but it's more of the dual frequency paper. The current paper that Ron sent us originally. That one, they used very low number of num shots, like up to 100. Yeah, whereas our method, we need like 10,000, that kind. Yeah, so as a result, their comparison in their own paper was like, they only compared between that 100 range, Whereas right now, we're trying to find like the compare in the 10,000 range, that kind. Might not be a direct comparison, might not be a good comparison, but like I'm missing that data. It could be from another model as well. It works too. It's just we don't need, but our option is to have something to compare to, and I don't have that something even from that paper. Yeah, that's what I meant.
Yeah, so maybe I can share something regarding that as well in the thread.
Yeah, I guess you can do that then. Then I don't think we have other stuff to discuss. If y'all have anything else, anything that is unclear.
No, not from my side.
Okay, then I think we
Okay.
can
Perhaps next meeting we will have to speak about the writing of the paper. So if
I
some
don't.
of you want to start to make a draft, something like that.
Okay, regarding the next meeting that we have as a group, right? I don't know if you all saw the message in the Slack, but I probably won't be there. But I'll write my report as detailed as possible, so y'all can look into that if y'all want to. Yeah, but writing the paper, do y'all want to create an overleaf right now, or do you want to leave that to later? Actually, it might be good to just start writing up some stuff. Actually,
I have to do. I have to write all my LaTeX thing in our lead. So if you, for example, if I understand you well, you are going to make a, let's say, a complete draft, a complete report because of your absence in December. So perhaps we can start to write the draft of our paper in our lead, perhaps using me, and share the project to us for write all of them and all about the project there. Sorry.
Okay, so just to clarify, the one that I'm writing for the group discussion and report, it won't be it won't be that detailed. It's just a
Okay.
normal weekly report that's more detailed. Yeah. Okay, but also overleaf, do y'all want to send your emails now, or do y'all want to use the usual emails? I can just create the document.
I have the same email, but I can put that in the chat.
Sure, I can like literally create it right now. Overleaf. Where's the chat? The chat is here. New project.
Also, like I talked with Ron, and he said a point could be in the paper, like the execution of the algorithm on real hardware. Like, can we access execution in all hardware, or like maximum on a simulator or something like that? Maybe should we consider that?
Okay, so firstly, Christian, are you gonna send your email here, or should I take your your other email?
I
Or
wrote
overleaf?
in the chat.
Huh?
I wrote in the chat.
Okay, yeah, okay, I'll do that. Okay, and then regarding Aditya's question, I think we should be using quantum hardware, right? And by right, like IBM's one, like the simpler one, should be available. In fact, I noticed recently that their 127 qubit one is available, but the waiting time is like 3 hours, but it's at least usable technically.
Yeah, I can, be in the wait list. I have the downtime as well, because some papers also used like an M node cluster of quantum computers, and they showed how the like algorithm requires essentially constant time. So we can show that stuff as well. We're using like real term quantum computers, and also the noise thing, how the noise affects it, depending on commercially available quantum computers.
Yeah, maybe you can look into a hardware side. And I wanted to say something. Oh, let me know like because I'm working on our model and like creating the model sort of. Y'all can work on it too, but since that's what I'm working on. So if y'all need like specific specifications with regard to hardware, like for example, the hardware can only handle 7 qubits or something, like yeah, I can take note about that. Or for example, since it's difficult to execute like many rounds, because right now it's like separate executions, and the wait list won't be very nice to you with that. So maybe I can ask Ron if I can do like 10,000 at a time. I don't know how well that will go either, but it's better than separate ones, I think. Yeah, like if you're looking into hardware and need that kind, you can tell me in the Slack. Yeah.
I also recently got like an access of this cloud quantum. They named it cloud, but this is essentially like accessing their own quantum computer. But the company's a startup here in India, so they don't have that much time in the waiting line. So I can access that much more easily. But I don't know how the like results will compare in terms of the ones that the IBM has. Maybe that is worth a shot it takes a longer time, but I will execute on the IBM one for sure.
I'm okay. Overall, I think you can discuss with Ron that, because I'm not sure what's the state of the art quantum computers right now, to be fair. Like the noise and stuff, IBM has like 127, don't know how many qubits quantum computers, but I don't know the noise, for example, unless Christian has something to add about that. Or if not, you can ask Ron about that. Yeah.
No.
Yeah, then I think that's all. If y'all have anything else, I also just send the overleaf invite if y'all, yeah, y'all can do it on your free time. Yeah, about that. If anything, you can ask me about Slack on Slack if the overleaf didn't send properly or something. Yeah. Anything else?
Nope.
Nothing from me. Yeah.
No,
Yeah,
nothing from me.
Then I think we can go enjoy your weekend stuff.
Thank you so
Bye.
much. Bye.
Thank you.
Good work.
Good
Bye.
work, everyone, too. Yeah. Bye.